The assembly of Nellore cattle genome is a revolutionary achievement for the future of the breed. Using technology to see in advance what is inside an animal with the analysis of the DNA is the whole concept behind the use of genomics for selection.
Brazil is the second largest producer and largest exporter of beef in the world. Here we are at Uberaba, ground zero for the Brazilian beef industry. This is where it all started.
They're also becoming world leaders in the use of genomic tools to improve the production and reduce the impact on the environment.
The lineage of Nelore that we breed in this farm is the oldest one that we have in Brazil. It was introduced in this country in 1878.
In 1988, the Nellore breeding program was officially founded, being coordinated by what is known today as the National Association of Breeders and Researchers, ANCP. That program is designed and conducted by researchers from universities all over Brazil and abroad.
Why is the Nellore breed so important for the Brazilian economy?
It's very tolerant to heat, to hot weather, and also it's an animal that resists to parasites and diseases.
How would the genomic data look?
To start working in depth in any species, you need to have a reference genome. The deep sequencing of an individual from the Nellore cattle breed has allowed us to assemble a genome with a very high resolution in less than 2 months. And this was a huge achievement. And then we sequenced several others to rescue the variation. And this variation we call SNP, single nucleotide polymorphism.
How would you interpret this data?
We took the animals that were more white in coat color and the ones that had black, gray coat color. By doing that, we could easily find a region where the gene is determining this coat color.
How do you study complex traits?
So complex traits are those that are determined by several genes. So to deal with that complex information, you have to have a whole set of animals, genotyped and phenotyped. One example is early puberty. The cows don't get in puberty until they are 24 months, but some of them get at the age of 12 or 14. If you could use genomics to find which regions of the genome are associated with that trait, you could use that information to push the whole population to come to puberty earlier.
How does the process work?
It's an easy process. You should have a biological sample, such as a hair with a root, and this hair is brought to the laboratory, DNA is prepared, it's loaded in a SNP chip, and that provides you a very, very vast results.
How would that impact the cycle of genetic selection?
Instead of waiting several years until the animal grows, become an adult, have a progeny, and you test that, you can easily do that even when it's still an embryo.
Genomic selection has an extremely positive impact on the increase of accuracy related to the EPDs. The EPDs are nothing more than an estimate of the genetic value of an individual as a parent.
Selection is the act of choosing the best animals. To choose the best animals, you need data, you need interpretation of the whole herd to choose the best one. And nowadays there are some computerized programs that give us the tools so we can choose the best animals according to our wishes.
The Brazilian Association of Zebu Breeders operates all over the country. We have a data processing center with our own team, and there is real-time monitoring of all the information that is collected by more than 100 technicians working all around every state in Brazil. Over time, ABCZ has collected more than 16 million registered animals from all Zebu breeds. Last year, we realized our first genomic progeny test that we call programmed reproduction, where all the candidates have genomic evaluation. That increased the accuracy, which before was 24%, to an accuracy of 56%, a huge improvement.
In the past, we've been screening something like 25, 30 bulls a year. With genomic EPDs, we can now screen 300. With accuracy of up to 85, 90% at 2 years old, the genetic gains have been exponential since we started with genomics. Brazil today produces 11 million tons of beef from something like 200 million head of cattle. Once Brazil reaches the same production levels that we have using genomic EPDs, then we'll be producing either 17 million tons of beef, or the Brazilian herd can remain static and we'll be sending back to agriculture 60 million hectares of pasture.
World population is growing. Brazil has an important role on feeding those growing population. Our system of production is natural, is on pasture, on green pasture most of the year. We do not use grains in most of our production, so the Nelore do not compete with people being fed.
Where do you see the future?
The future for me is the possibility to use technologies such as genomics to have animals that would grow fast, would convert grass in beef in a better way, and also animals that could be sustainable for such very interesting environment.